Good day everyone, I'm Joshua Miguel Orelota of BSECE3A and I will discuss about DPCM, which means Differential Pulse Code Modulation. Differential pulse code modulation is a technique of analog to digital signal conversion. This technique samples the analog signal and then quantizes the difference between the sample value of its predicted value, then encodes the signal to form a digital value. Before going to discuss differential pulse code modulation, we have to know the demerits of PCM pulse code modulation. The samples of a signal are highly correlated with each other. The signal's value from present sample to the next sample does not differ by a large amount. The adjacent samples of the signal carry the same information with a small difference. When these samples are encoded by the standard PCM system, the resulting encoded signal contains some redundant information bits. The figure shows a continuing time signal xt denoted by a dotted line. This signal is sampled by flat top sampling at intervals ts, 2ts, 3ts, and ts. The sampling frequency is selected to be higher than the Nyquist rate. These samples are encoded by using 3-bit 7 levels PCM. The samples are quantized to the nearest digital level as shown by small circles in the above figure. The encoded binary value of each sample is written on the top of the samples. Just observe the figure at samples taken at 40s, 50s, and 60s are encoded to the same value of 110. This information can be carried only by one sample value, but these samples are carrying the same information means redundant. Principle of differential pulse code modulation. If redundancy is zero, then the overall frequency and the number of bits required to transmit one sample will also be zero. This type of digital pulse modulation technique is called differential pulse code modulation. The DPCM works on the principle of prediction. The value of the present sample is predicted from the previous samples. The prediction may not be exact, but it is very close to the actual sample value. Differential pulse code modulation transmitter. The figure shows the DPCM transmitter. The transmitter consists of a comparator, prediction filter, and an encoder. The sample signal is loaded by X and TS, and the predicted signal is indicated by X prime. The comparator finds out the difference between the actual sample value. Error signal EQ and PS is very small and can be encoded by using a small number of bits. Thus, the number of bits per sample is reduced in DPCM. The quantity per output will be written as EQ and PS is equal to NPS plus Q and PS. Here, Q and PS is quantization error from the block diagram. The prediction filter input by some Quantized version of signal XQNTS is the sum of original sample value and quantized error QNTS. The quantized error can be positive or negative, so the output of the prediction filter does not depend on its characteristics. Differential pulse code modulation receiver. In order to reconstruct the received digital signal, the DPCM receiver consists of a decoder and prediction filter in the absentee sum of noise. The encoded receiver input will be the same as the encoded transmitted output. As we discussed, the predictor undertakes a value based on the previous output. The input is the encoded number of bits is that it uses 4, 8, or 16 bits per sample. DPCM less than PCM bits. Level step size. Fixed step size cannot vary. DPCM, a fixed number of levels are used. Bit redundancy. DPCM, bit present. DPCM can permanently quantification error and distortion depends on the number of levels used. DPCM, loop overload distortion. Applications of DPCM. The DPCM technique mainly uses speech, image, and audio signal compression. The DPCM conducted on signals with the correlation between successive samples